So this video is being created thanks to Steve Gardner, who has asked a question on YouTube. And if you want me to create some personal videos for you, go ahead, send us your questions and comments, and I'll try my best to get back to you. My team helps me with fielding and answering questions, but sometimes they do flip them off onto me, and I'm happy to address them personally. So he asks, do your engineers have a recommendation for safety margins? How much crystal should not be internally etched so that the crystal does not break, assuming I can't start internal etching exactly at the edges of the crystal? Also, with respect to internal etching depth, what is the minimum required internal depth for internal etching for good image? And also, I think I've learned that a high density of dots while producing a more detailed image also creates heat. Is there a way to pause the program for cooldown period and then have it restart? So I'm going to take you through an actual sample, an example of how you can use Cockpit3D to create a point cloud and address these questions you have around margin and depth. What I will say is that the very fracture happening or occurring within the crystal is because of heat, right? So the way it works is that you have the laser coming out of the laser head. It then reflects through various different galvos and mirrors through the lens. The lens is similar to the magnifying glass that you used in the schoolyard with the sun going through it, burning a leaf, right? So in this case, what happens is we're splitting the ray bundles of that laser, and then we're causing them to reconverge by using that lens. And we're defining a point on the XYZ axis where those beams will reconverge. That reconvergence point exerts enough heat to create a microfracture, and millions of microfractures or points or cracks later generates the perception of your image inside. Now, I don't feel there's a need to be pausing or stopping your laser in order to cool the burning process down. If it's going to crack, it eventually will. That is controlled by the point space settings. If you really did want to stop your laser, there should be some sort of a pause button on your laser machine. You can pause it and then continue the burning later. But again, I don't think that this here is a variable that you'd want to use as far as the process is concerned. So let's take a look at this picture here. Now, if I wanted to put it, for example, in, let's just go with the standard 3D rectangle 8050 to start. Okay. Oops. There we go. I'm just going to auto size it, and I'm going to look at it from the front. You'll see that these here are the edges, and we have, because our crystals, when you source from us, have these beautiful facets or bevels. So we've kind of programmed that in. So when you do purchase from us, you're actually getting product that is one for one with what we have programmed in Cockpit3D. Now, if, for example, you are using a crystal piece from elsewhere, simply go to the settings here and just change them. So for example, I can change my margin settings and my bevel, which is that bevel there, to 0. And now you have no margin. And essentially this is how most crystal comes, right? Without any sort of a facet or a bevel. So if I were to take this image, size it, let me just check my point space settings here. So for a 3D laser box, we use 0714 and we use projection 852. Save, okay, and go. Well, we see the point cloud comes right to the edge. And so therefore, when the laser is striking, the laser too will come to the edge. And this could very well result in cracking. There are times where when you take it out of the laser, it will look fine to you. But by the time it is shipped and arrived at the customer, it has actually resulted in those cracks spreading, which were invisible to you when you first looked at it, but actually making its way from the surface through and destroying the image within. So to be safe, what we always recommend is to have a margin. So again, the bevel is that kind of beautiful facet that we have. You don't really need to put that there. You can simply just work with straight margins. And so we recommend keeping 3 millimeters along the X, the Y, and the Z being the depth. So if I look at it from the side, this part over here, okay? So let's remake this now, and I'm just going to size this a little smaller. And Cockpit3D is designed to be quite smart to trim along the internal margin line. So even if it's going outside of the margin, it will complete the point cloud nice and tight within. So the question becomes, how many points can you safely do inside the crystal without this chance of it kind of breaking apart? Look, we've never tested any sort of a threshold. Usually what you want to do is you want to make sure that your point space setting is good. So if your point space setting is, in the case of UV 0606, you have less of a risk of it internally cracking. If you want to go higher resolution and more denser and more points, it's not necessarily the number of points that's going to cause it to crack. It's the closeness of those points. Because those points are so close to each other, they are going to have a higher chance of melting into each other and cracking into each other, if not directly at the time of the impact of the lasers intersecting, a little later on, it just might happen. So you want to be very, very cautious of this when you're starting to tighten points to get higher resolutions. The other question was from the Zed, how deep do you need to go? Look, you don't need to go very deep. I recommend, first of all, let me just show you something that's bugging me here, is I really don't feel that this is 3D enough. And so the other power of Cockpit 3D is that you can stretch it. Isn't that cool? So I really wasn't happy with what I was seeing there. So stretch it, 0714852, save, okay. And let me just show you what the difference is. This was before. I'm just gonna click on go. And this is after. All right, I'm much happier there. So as far as depth is concerned, again, if you're going to burn very close to this outer edge, you'll risk cracking, but as long as you're about 3 millimeters in, you're okay. For smaller articles, such as keychains, for example, 3 millimeters might be a bit much, so you're okay to do 2 millimeters in that case as well. Now, while we're on this topic, how do we handle margins when we're dealing with shapes that have curves, such as hearts? So let me just quickly share that example with you. If I go to the 3D heart small, and I zoom in here. All right, so in this case, what you can do, you'll notice here that if I try to put a margin, let's say I put 3, 3, and 3, it is going to treat this as a rectangle or a square. You see that? So what we want to do, instead of having it done that way, is yes, I will keep my Z at 3, if in case I just wanted to be cautious. Nothing's close to it anyway, so it's irrelevant, but let's say I was working with text. Maybe this would be a good guide to make sure that I don't put my text too close to the front surface. So here's my text, and this way I know that, okay, I should not go out here, I should keep it here, right? So the Z is a good idea. I'm going to delete that layer anyway, but how do we create a perimeter or some sort of a margin around where my daughter's arms are here, my daughter's hand here, and my arm over here? So the way we do it is we use what's called light maps. So you see here, there's light maps. If I turn that on, it creates this beautiful fading effect. And you can actually control the power of that with what we call the blur radius. So now you'll notice I'm starting to get a little deeper into what these settings are. Before, we've always just talked about these two fields, and we've always talked about this here. We haven't talked about anything else. So now you understand blur radius is going to impact this. So the smaller the blur radius, the less powerful the light map. So you see now it's less powerful. And alongside that, you have a fall off exponent. So this is how quickly do you want those points to fall off to the edge? Do you want it to be very, very quick and very sharp, or do you want it to kind of slowly trail off? So I'll show you. If I make this 3 and I make this 3, it'll be a very sharp, well, let's actually make it 10. And you should see somewhere around 10 millimeters, 1 centimeter. It takes a bit longer because it's a bigger calculation the higher the number goes. So give it a second, it'll do its thing. There we go. So it's actually even more. There's a bit of a factor here. So you'll see it's even more than 10. So generally we find 3 and 0.5 is good, but let me just show you. I kept this at 10. Now let me change this to 0.5. You should see that it starts somewhere around here and slowly trails off, okay? Watch. So it's not as obvious of a sharp cut like it was before. It's kind of slowly fading out. You can actually still see a bit of my hand here as it goes to black. So the right setting for this, at least from our experience, is 3 and 0.5, and then it'll be nice and safe. That's a safe enough margin to keep the laser away from the edge of the crystal. I hope this answered your question, and I hope it helps. Thanks for watching.